Okay, I'm going to do another one of these rational functions just so that we can have it available to look at as needed to try and graph these. So here we have our function x squared plus x plus 3 all over x plus 2, and we would want to see if we could factor this, which the numerator won't because we don't have any pair of numbers that's going to multiply to make 3 and add to make a positive 1. So we know that it's not going to have a discontinuity because we're only going to have discontinuities when we have something that will factor and cancel out. So we do not have any removable discontinuities. When we're looking to find our x-intercepts, that's when we're looking for our solutions of our numerator. So again, since we can't factor it, we can go ahead and use our quadratic formula. So we're going to have our opposite of b, opposite of 1, plus or minus the square root b squared, 1 squared, which is 1, minus 4 times a times c. 4 times 1 times 3, so minus 12, all over 2 times a. So what this is going to give us is our negative 1 plus or minus the square root of negative 11. And we can actually stop right there because we know that we aren't going to have any real solutions for those x-intercepts because of the square root of negative 11. We don't have any. They're imaginary. So we have no x-intercepts either. So it's not going to cross that x-axis. So when we're looking for our y-intercepts, we can keep going with that. That's going to be our ratio of our constants. So our constants over here being 3 over 2. So our y-intercept is going to be at the point 0, 3/2, or 1.5, 1.5. So I could get that plotted up here, 0, 1.5. That's our y-intercept right there. I can get my vertical asymptote. That's going to happen where our denominator equals 0. So our vertical asymptote is going to happen at x equals negative 2. So I can plot that one up here, like this. And then thinking about our end behavior asymptote up here, looking at our ratio of our leading coefficients, I have 1x squared in my numerator and I have 0x squared in my denominator. I have a top-heavy function here. I have a higher degree in my numerator than in my denominator, which means we are going to have a slant asymptote. That means I need to do some division in order to figure out what that line's going to be. So I'm going to take my root, my solution of the denominator, so that's my x plus 2 equals 0, or our negative 2. It's going to wind up being the same thing as our vertical asymptote. And we're going to use those coefficients in our numerator to set up a synthetic division. Switch colors real quick. So we're going to have our 1x squared plus our 1x plus 3. And we're going to do that synthetic division. So we're going to drop our 1. 1 times negative 2 is negative 2. We're going to add here. We get a negative 1. We can finish it out just because it feels weird to leave it half finished. Negative 1 times negative 2 is positive 2, and we get a remainder of 5. It's irrelevant that 5 doesn't really do anything for us. It just feels weird to leave our synthetic division halfway done. So what this gives us is the equation of a line where this is our x and this is our constant. So we're going to have our y equals 1x plus c, or plus our b here, minus 1. And these two coefficients give us this line, and this is what we have as our horizontal asymptote or slant asymptote. So it's going to be at the equation y equals x minus 1. Well, when we try and graph that up, x minus 1, we have a y-intercept at negative 1, and our slope is 1. So we're going to up 1 over 1. And we're going to wind up with a slant asymptote that looks like this. And we can use that to kind of help us figure out what this is going to look like. With the intercept that we actually have enough information to figure out what's going on the top right. And then we'll just have to figure out what's going on the left-hand side. So because of that y-intercept, I know it's got to come and try and approach this asymptote, and it's going to come and try and approach this asymptote here. We just got to figure out what's going on the left-hand side, whether it's up here making this kind of big shape, or if it's going to be this really skinny one over here. So the way we can figure that out is we're just going to substitute in a point. So I'm going to pick a point that's to the left of my asymptote. Maybe I'll use negative 3. So if I use f of negative 3, and substitute that in, that's going to give us a y value that we can use to help substitute pieces in. Or we can help get our points, we can figure out what's going on. So if I substitute in -3, we'll have -3 squared, which is going to be a positive 9. So we'll have 9. And then we have add -3 plus 3 over our -3 plus 2. So when we do that, we wind up with 9 over -1, or just -9. So when x equals -3, y equals -9. So that's going to put our point down here. With that point, what we can see is that this function is going to approach both of these asymptotes, and it's going to look like this. So that's just going through another one of those slant asymptotes for us, so we can see what that looks like. We do have in here, in truth, that we do not have any x-intercepts, so we do not have anything here. We didn't get any removable discontinuities. It's matching what we're looking like over here. So that's how we would graph this function here.